Okay, hi. Today we are going to start with a new topic on Fourier series. Okay, so what is Fourier series? Fourier series is a mathematical way to represent non-trigonometric periodic functions as an infinite sum of trigonometric functions. So for example, in this graph, we can see that it is a periodic function. So the function comes up and go down, up over and down over again, where the function is repeating along the graph. Okay, this pattern we consider as a periodic function where it's repeated after a certain period. So in this graph, the original function may be seen from negative pi to pi. So it means that the function repeats after 2 pi. So we are going to plot the function that can represent a piecewise function like this, known as a Fourier series. So the function of Fourier series can be even, odd, or neither function. So we will go more deeply on the even and odd function first. So there are two ways to determine whether the function is even or odd. Okay, so for the first, we go to the even function. It has, when we substitute negative x into the function, then we get back the function where it has x only. Okay, while for the odd function, if given a fx, then when we substitute negative x into that function, then we will get back equal to negative fx. Okay, so this is the first option to distinguish both functions. So the second one is by looking at the graph. So the graph of an even function is symmetric with respect to the y-axis. Okay, so we have x and y. So y-axis, it is symmetric, means it reflects. For example, if I have this function on the left side, then it will get this function. So this one we consider as an even function. Okay, while for the odd function, it is symmetric with respect to the origin. Okay, so the origin means we have x and y. So this is origin 0, 0. Okay, 0, 0. So for example, if we have this function on the left side, okay, so it symmetric on the origin, so means it might be on the right side like this. Okay, so it reflect on the origin. Another way is by looking at the reflection, which it's supposed to be reflect on the y-axis on and x-axis. Okay, so let's say if we reflect on the y-axis, it should be like this, and when it reflect on the x-axis, it also occur on this side. Okay. Okay, before we proceed to the example, let's talk about the symmetry at origin. So what does it mean? So what is origin? So the origin is actually the central point here where it has the value of, if we have two axes, so we have 0, 0. Okay, so it is the value of the origin. So it is symmetric when every part has a matching part. So what does it mean? It has the same distance from the central point but in the opposite direction. So how to check that one? So if we have for example, we take the value of x, then we take the location of negative x. Okay, so it will be in the same distance from the origin. Okay, we go to the example, determine whether the following function is even, odd, or neither. So we have 6 example here. I will just go through for 3 example. Okay, we go to the first example. We have fx equal to x power 3. So what do we do to determine whether it is even or odd? We need to substitute the value of f negative x. Okay, to check for the even, we need to substitute for negative x and also for odd function. Okay, f negative x. So when we want to substitute, we will make sure that every single x will be substituted by negative x. So we have negative x here. Make sure to put it in bracket power 3. So this one is equal to negative 1 multiplied by x, right? Power 3. Okay, equal to negative 1 power 3 multiplied by x power 3. Okay, negative 1 power 3. 3 is a number of odd number. If you use calculator for any odd number, you will get negative 1 back. So you get negative 1 multiplied by x power 3. So this one is equal to negative x power 3 is similar to the our fx, previous fx. So we put fx here. So since f negative x is equal to negative fx, so it is odd function. Okay, we go to the second example. Here we have for c. Okay, I just take c. We have fx equal to x squared minus 2x plus 1. So this is fx. Next, we substitute to check for the even and odd. Substitute negative x. So we have negative x, make sure to put in bracket, power 2, okay, minus 2, multiplied by negative x plus 1. So we have x power 2, okay, negative, power of even number, okay, so we will always get positive, plus 2x plus 1. So check, is it equal to fx? So here is fx. So there is a difference. Okay, so the difference is in terms of plus and minus here. Okay, so we consider that the function is not equal to fx. So we have checked the criteria for even. So it is not even. Not even, eh? So we need to check also for the odd function. Is it equal to negative fx? So since the fx is not equal, so automatically it is also not equal to negative fx. So it is not odd. So the answer is neither. Okay, we go to the last example here. We have fx equal to cos 2x. So we substitute f negative x equal to cos 2 negative x, right? So equal to cos negative 2x. Alright, so can we bring negative out? No, we cannot bring any value inside the trigonometry function. So what can we do to simplify the negative here? So maybe we can try for any values first. Okay, so let's say we try for, I put a table here. We have for cos, we need to check cos x, and we have also cos negative x. We want to find the relationship between cos x and cos negative x. So let's say if I try to substitute with cos pi. Okay, if you use calculator, make sure you put it in radian, or if you don't want to put in radian, you use degree, cos 180. Okay, cos 180. If you find out using calculator, okay, I have my calculator with me now, so I get cos pi is equal to negative 1. Okay, so how about if I put cos negative pi? Okay, it's cos negative x here. We substitute with cos negative pi. So we will get negative 1 also. Okay, so how about if we try another example, cos 70. I try with random value. Cos 70 will get 0.342. Okay, so how about if we try cos negative 70? We will also get 0.342. Okay, if you try for any value, we will find out that cos x, cos negative x is actually equal to cos x. So we get this formula not because negative we bring out or we simplify it, because based on the any value we will get the formula of cos minus x is always equal to cos x for all value. Okay, so we substitute into this one, simplify for this one, so we will get cos negative 2x is equal to cos 2x, right? So cos 2x is equal to the previous one we define as our fx. So since f negative x is equal to fx, so means it is even function. Okay, so maybe this one is true only for cos. Okay, for sine maybe we need to solve for the same way. Okay, to find out the relationship between the sine negative x and sine x. Okay, so this is the solution for the previous example, so you can try by your own. And so some notes from here, we can summarize that even function will have the formula f minus x always equal to fx, while for the odd function we have f negative x is equal to negative fx. And we also figure that cos negative x equal to cos x, while for the sine negative x is equal to negative sine x. Okay, next we want to determine even and odd function when we are given a graph. Okay, so based on the previous explanation, we know that for the even function, it must be symmetric to the y-axis. Okay, while for the odd function, it must be symmetric on the origin, or we can say that it is also symmetric on the x-axis and y-axis. Okay, if it satisfies both reflection on x and y, okay, we can also say that it is an odd function. So let's go to the first example here. So first graph, we have in this graph we have three functions. Okay, so let's look at the function on the left side. Okay, left side means that on the left side from the y-axis here. So this, imagine this is a mirror. Okay, so on the left side we have two functions. So the first function we have from negative pi to negative pi over 2, while for the second function we have from negative pi over 2 until 0. Okay, so for the first function here, so the length here from the function towards the y-axis here we have pi over 2. So when it reflects on the y-axis, the function, okay, has the reflection on the right side. Okay, because why I say that it is a reflection, because the length is similar. This is pi over 2, the length here, and the length here also pi over 2. It is like a mirror image on the y-axis. Okay, so same goes to the second function here. We have y equal to 4. Then when it reflects on the y-axis, we get the similar length of that function on the right side. Okay, which is also a reflection on the left side. So we can say that this function, okay, the piecewise function is actually even function, because both function, okay, all the functions here are the reflection on the y-axis. Okay, it reflects on y-axis. Okay, so we look at the second example here. So we have two functions, okay, on the left and right side here. So we just look at the left side. Okay, so we have one function. So imagine this is a mirror image of y-axis. We want to see whether it is reflect or not on the y-axis, because y-axis indicate that it is an even function. So let's look at the left function. So we have this, and then after if we imagine if it reflect on the y-axis, okay, it should be in the length of 3 units, okay, because -3 to 0, so it should appear on the right side like this. Okay, I put the line here. So it does not appear actually in the right axis, okay, because so it means that it is not even, because it is not the reflection on the y-axis. Okay, so let's look at the reflection on the x-axis. So we have checked when we reflect on the y-axis, we get the dot, the line here. Okay, so we try to reflect on the x-axis, so we have the length here 2, so it must be also the length 2. So the function, the reflection, okay, is similar to the function appear on the right side here. Okay, because the length, the distance here is 2, okay, it has the same distance, so it is the, we can conclude that it is the mirror image of the x-axis as well. Okay, so we can say that the both function are reflection on x-axis and y-axis, so means it is an odd function. Okay, so we can conclude that because it is also reflect on the origin, okay, or reflect on the x and y axis. Okay, and then we go to the third example here. We have two functions. Okay, we just look at this function, okay, at this length. So first we have y, we want to see about the y reflection. So the first function here, we have the length of pi. Okay, so when it reflect on the y-axis here, it should be on this line, right? Okay, but the function on the right side is not similar to the supposed to be the reflection, so it is not reflect on the y-axis. Okay, so we need to check also for the reflection on the x-axis. So it is also not possible to reflect on the x-axis because the function occur in the similar quadrant, so it does not appear on the other quadrant, so it also not reflect on the x-axis, so we can say that it is a neither function. Okay, because it is not reflect on the x-axis or y-axis. Okay, so it's just a shifting function. Okay, shifting function means that it is not reflection, it's just a shifting.